Previous lesson, we explained the linked list, that what a linked list is and how to create a linked list. And today we will focus on some basic operations that you need to know in order to solve some problems relevant to the linked list. Those operations are creating a linked list. We already know how to create a linked list. We explained in the previous lesson that we need two classes. One of them is the node and the other one is the linked list class. However, today I will focus on the insertion and specifically how to insert a new node at the beginning and how to insert a new node at the end of a list. Because if you know how to insert a new node at the beginning or at the end of a list, that means you can insert a node anywhere that you set the condition for. Okay, so let me explain that in that graph in the list that we have here. Now it is our list, and I want to insert a new node. For example, I have a new node and I want to insert this at the beginning of this list. For example, the value of this node, let's say it is 40. So I want to insert this node at the beginning of this list. So in order to insert this at the beginning of the list, that means that the head of the linked list has to point to this new node. In our previous lesson, we explained that the linked list itself, that's actually a pointer to the first node. So right now here we see head points to this node. It is the current first node. So we want this node to be the current first node. And if this should be the current, that means it should be the second. And technically, from programming perspective, what does that mean? That means that the pointer of this node has to point to the current first node, like this, so that it should be first node in the list. And in order to make it first, so the head has to point to this node instead of pointing to this one, like this, and not this one. Okay, now let me write that in programming in JavaScript. That how do we write a code for that? For example, okay, let me move it a bit higher so that I can see that here. I create a new function for inserting a new node at the beginning. Insert at the beginning. So we pass the value. This function has to have a value. And in programming, when you insert a new node at the beginning of the list, so that means first you create an object of your node, and then you insert at the beginning of the list. So first create the object, say let a new node equals a new linked list node. So pass this value to as the value of this node. Okay, so now this node is created here, and if you want to make it the first node, so I said that the pointer of this node has to point to the current first node. So I'm saying that a new node dot next has to point to the current first node, and the current first node is this one, and this memory address is stored in the head. So I'm saying that this dot head. So now both head and this node points to this node, but after this time we are saying that head does not have to point to this one. Instead, this dot head has to point to this new node, so that it should become the new head. This dot head equals to new node. It is as easy as this, like how to insert a new node in the beginning. So now let's insert a new node at the end. For example, I have another node here, and its value, let's say 50, and its pointer has to point to null. So right now this list, it is the last node, and its pointer points to null. So if you want to insert a new node at the end, that means first we have to find the current last node. And how do we find the current last node? We have to start looking from the head until today's node, until the node that its pointer is null. That any node that its pointer is null, that means that is the last node. So if that is the last node, if we could find that, so automatically we say that its pointer has to point to the new node instead of pointing to the null. So how do we do that? For example, I create a specific function to insert a new node at the end of a list. So I'm saying insert at the end. Okay, this function also has a value, the value of the node. So create the new node, because you know that when you say you want to insert a new node in the list, that means you should have a new object of the node. Let new node equals new linked list node, and pass the value. So sometimes, as a general rule, there is a possibility that the list can be empty. If the list is empty, that means you don't need much operation. The new node, that becomes the last node, and the first node, that is all the element that they have in the list. So how do we check that? We check that if head is still null, that means if head does not point to anything, if head is null, we can say like this, or we can say like if head equals null. If head is null, that means it's an empty list. So this new node become the head. This dot head equals new node. That's it. But if the head is not null, that means there are some nodes in the list. So if there are some nodes in the list, so we have to start looking from the first node up until the last node, which its next is null. When we find that, that means that is the last node, and its next has to point to the new node. So let's create like a variable to iterate through the list using that variable. Let current equals, let's start from the head, this dot head. Okay, so we say as far as this current node, which right now it points to the first node, as far as the pointer of this node is not null, while the current dot next is not null, we have to go one step ahead. For example, right now current is pointing to this one, this dot head. That means it is the memory address of this node. So when we say current dot next, the current dot next of this node, it is not null. So if it is not null, current has to come from this node to this node. So I'm saying that current equals current dot next. So now current is here. So again the loop continues. We say when we're here, current dot next, is it null? No, it is not null. So again, current has to come from this to this point. So we say current equals current dot next. Now it is here. So when we are here, is current dot next null? Again, it is not null. So if it is not null, the current has to come here. So we say that current equals current dot next. So current dot next is this one. So the loop again continues. So at this point, when we say is current dot next null, it says yes. Current dot next is null here. That means we found the last node, and this condition does not execute, so we come out of the loop and we say that right now we have the memory address of this node in the current. So we say that this pointer has to point to the new node. So we say that current.next, right now that current is here, current.next is null. So we say that after this one, current.next has to point to the new node. As easy as this. So right now, this points to this one, and no longer it points to the null. So it was all about how to insert a new node in the list. The key point is that you should learn the concept of this pointer. So if you know the concept of pointer, and pointer means actually storing memory address of a node. So that way you can easily insert a new node and at the beginning or at the end. And if you can insert a new node at the beginning or at the end, that means you can insert any node anywhere that you set condition for them. Okay, that's all for today. And if you have any question about the insertion, comment. I will consider them in the next lesson. Have a nice time.